Simplify tangent of arc cosine of x. So the way that we solve these problems, where we have a composition of a trig function and an inverse trig function, is by looking at that inverse trig function and defining it to be theta, and then making a right triangle that fits this particular relationship. So we've got this theta here is equal to arc cosine of x. And what that means is that cosine of theta is equal to x, or x over 1. And so what we need is a right triangle that satisfies this relationship. So here we've got our angle theta, and we know that cosine of theta, which is adjacent over hypotenuse, is x over 1. So we can put an x here and a 1 there. And then if we want tangent of arc cosine of x, that just becomes tangent of this angle theta. And we know that the tangent of an angle in a right triangle is the opposite over the adjacent. And so we need to know what the length of this opposite side is. And for that, we use the Pythagorean theorem. A squared plus b squared equals c squared. In this case, one of the legs is x. We don't know the other one. And the hypotenuse is 1. So this becomes x squared plus b squared just equals 1. To get b alone, we subtract x from both sides, giving us b squared equals 1 minus x squared. And then when we take the square root, we get b equals the square root of 1 minus x squared. So that is going to be that. And then remember, to get tangent of arc cos of x, we need just tangent of this angle theta. Tangent is opposite over adjacent, so that is going to end up being the square root of 1 minus x squared over x. And that is what we get with our composition of functions. With all of these, we end up doing a similar process. We assign theta to be the angle that is the arc cosine of whatever the inside is, or arc cosine, arc sine, arc tangent, whatever the problem gives us. And then we make a right triangle that models this relationship. And then we can use the Pythagorean theorem to figure out the missing side. And then once we have all three of the sides, we can evaluate tangent of that angle or cosine or sine of that angle, whatever the problem calls for. And whatever that ratio is our answer. So again, we have a composition of a trig function and an inverse trig function giving us an algebraic function in the end.